6-3, Day 2, double angle, power reducing, and half angle formulas. Our learning goal is still the same, that you will be able to prove and apply trigonometric identities. Example 1, write the expression as a double angle, then find the exact value. Make sure you have your double angle formulas with you so that you can use those to answer the following examples or work them out. So let's say we had 2 sine 22.5 degrees times cosine 22.5 degrees. Well, looking at our double angle formulas, this is the form of sine, or the double angle of sine. And so what we're going to do is, since this equals sine times 2 times the angle, and our angle in this case is 22.5 degrees, I'm just going to take that and plug it in for theta. So it'll be 2 times 22.5 degrees, and 2 times 22.5 is 45. And sine of 45 is the square root of 2 over 2. Okay, continue with example 1. This is example B. Cosine squared of 105 minus sine squared of 105. That follows the same formula as cosine, or the double angle of cosine. And this time our angle is 105 degrees. So I'm just going to plug that in for theta. And 2 times 105 is 210 degrees. So if you do your unit circle, 210 is right here, which is the same angle as 30, or pi over 6, however you want to call it, 30 degrees, which is radical 3 over 2, comma 1 over 2. But the difference is, in this quadrant, they're both negative. And cosine is the x-coordinate, so the answer is negative radical 3 over 2. Okay, the last example is C, and this example follows tangent's double angle formula. And in this case, our angle is pi over 8. So if I multiply that by 2, I'm going to get tangent of pi over 4. And we should know that tangent of pi over 4 is 1. For example 2, we're going to verify each identity. And before we do that, we're going to just go back over the double angle formulas. So I have provided them for you. Notice that cosine, the double angle for cosine, has 3 different choices that you can use. And you just use which one would benefit you better. All right, for example A, I'm going to use the right side to help me because it looks more complicated. So first, and there's no right or wrong way to verify it because some of you all may use different identities to help you. But I'm going to start with the denominator because I know that 1 plus cotangent squared of theta is equal to cosecant squared of theta. And then I know that cotangent is cosine over sine. And then I know that cosecant is 1 over sine. And so if I do keep, change, flip, I'm just going to move this over here. And this is supposed to be 1 over sine squared theta. Keep, change, and then flip. That way, this sine is gone, and we have one more sine left. And then if you notice, I'm left with, and I'm just going to rewrite it, this, which is equal to sine double angle. And we have proven the left side equals the right. Okay, for the last example, I'm going to verify that the right side equals the left. And I hope I said that right for the last example. If I didn't, I apologize. So I'm just going to use the cosine double angle formula. Remember, there's 3 to choose from. I'm going to use the one that equaled 1 minus 2 sine squared of t. And the reason why I use this one as opposed to the other ones is because on the left side we have a sine. So now I'm just going to distribute, and I'm going to get negative cotangent t plus, because a negative times a negative is a positive, 2 sine squared t times cotangent of t. So I'm going to bring this down, and if you notice, cotangent is equal to cosine over sine. So this sine will cancel with one of these. And then this is equal to sine double angle. And then I'm just going to rewrite this, switching them around. And now my left side is equal to my right.